Welcome to Best Mechatronics. Transistors, the device that changed the world, the most important component in electronics. In this video, we will discuss the construction and working principle of transistors. Transistors can be thought as a versatile, very small electronic devices that can perform two functions. They can be used as a switch to control electronic circuits by switching on or off, and transistors can also act as an amplifier. A very small current given to the base pin gives rise to a large current on the main circuit. As it can be seen here in this demonstration, the transistor is used as a switch to control the state of the LED. As we give current to the base pin, the transistor switches on so that the LED lights up, and vice versa. Also, in the simulation, we can see that a small change to the base current gives rise to a large current on the main circuit. This is called the gain of the transistor. We can find this value for every transistor on the manufacturer datasheet. The value of the gain, denoted commonly by beta, can be calculated by the equation beta is equal to collector current over base current. In this example circuit, collector current is 149 mA and the base current is 1.49 mA. So beta would be 100. Transistors, which are the building block of microprocessor due to their binary functionality, are mainly two types. This classification is based on their use in electronic circuits: field effect transistors and bipolar junction transistors. Field effect transistors are also divided into two: junction field effect transistors and metal oxide semiconductor field effect transistors. Also, the bipolar junction transistors are divided into two as NPN and PNP transistors. For this video, we will focus on bipolar junction transistor, but if you have any question related to the field effect transistor, please let me know in the comment section. Bipolar junction transistors have three terminals, mainly the emitter, the base, and the collector. This is an NPN transistor. To know which pin is the base, collector, or emitter, we have to look to the manufacturer's datasheet by using the part number of the transistor. For this specific transistor, looking at the flat side, the left pin is the emitter, the middle one is the base, and the right pin is a collector. Transistors are represented by such a symbol in a circuit, and the arrowhead represents the conventional direction of current. When we look at the construction of a bipolar junction transistor, an NPN type bipolar junction transistor is constructed by placing one p-type semiconductor in between two n-type semiconductors, and the PNP transistor is constructed by placing one n-type semiconductor in between two p-type semiconductors. The semiconductor used commonly is silicon. If you are new to the concept of doping semiconductors, it will be hard to understand the working principle of a transistor. So let's discuss in short semiconductor doping. The illustration here shows the covalent bond of a silicon. Silicon has 4 electrons in its valence shell, and it shares each of these electrons with its neighboring atom to form a covalent bond. In this condition, the electrons are in their valence bond. In order for these electrons to conduct electricity, they must absorb some energy and become free from the valence bond. In its pure form, silicon is neither a good conductor nor insulator. Now, if you replace some of these silicon atoms with arsenic, which has 5 electrons in its valence shell, the 4 electrons will form a bond with their neighboring silicon atom, and there will be one extra electron hanging around. And since this free electron is not bonded anywhere, It's free to move or flow whenever voltage is applied. This process of adding impurity to semiconductors is called doping. And doping that results in free electrons or extra electrons is called N-type. On the other hand, if you replace some of the silicon atoms with gallium, since gallium have 3 electrons in its valence shell, they will form a bond with their neighboring silicon atom and a hole will be created, which again will result in the flow of electrons trying to fill the empty bond around the gallium atom. This type of doping is called p-type doping. A pure semiconductor is called intrinsic semiconductor, and a doped semiconductor is called extrinsic semiconductor. The way transistor works is mainly due to its construction. Taking an NPN bipolar junction transistor, it was mentioned earlier that it will have 3 regions: the collector, base, and emitter. As we put these doped semiconductors together, 2 junctions or depletion regions will be formed: base collector junction and base emitter junction. The emitter is heavily doped, the collector is also doped, and the base is lightly doped. Also, the base is very thin in size as compared to the emitter and collector. In a normal condition, the emitter base junction is forward biased and the collector base junction is reverse biased. A very small current applied to the emitter base junction eliminates the depletion region between the base and emitter and allows the flow of charged carriers, in this case electrons, into the base region. And since the emitter is heavily doped and the base is lightly doped, a very small percentage of the charge carriers, in this case electrons, that enter into the base region get a chance to combine with the available holes. Most of these electrons reach the collector base junction and are pulled away into the collector region by the higher potential that is available at the collector site. This is all we have for today. If you like the content, please don't forget to like and share this video. If you are new to our channel, please subscribe and also click on the notification bell so that you can see whenever we post a new video. Thank you.